Aloe vera has evolved from a traditional healing plant into one of the most relied upon natural ingredients in today's worldwide wellness, skincare, pharmaceutical, and health-focused industries, driven by a rapidly growing consumer preference for organic, plant-derived, environmentally conscious, and chemical-free alternatives. Its wide range of therapeutic qualities, including its soothing, cooling, antimicrobial, anti-inflammatory, antioxidant, hydrating, and skin-friendly properties have made it indispensable across countless product types, from skincare serums and natural gels to nutritional drinks and medicinal treatments. Because aloe vera is gentle, multifunctional, and rooted in both ancient traditional use and modern scientific verification, global demand for high-quality gel continues to rise at an unprecedented rate. Meeting this enormous and increasing demand requires a highly structured production system involving large-scale cultivation, expert harvesting teams, sophisticated processing technologies, and streamlined global distribution networks. Aloe vera's agricultural success is largely due to its ability to thrive in hot, dry climates where other crops struggle or fail. It grows best in regions with long hours of sunlight, minimal rainfall, low humidity, and sandy, well-drained soils. These ideal environmental conditions are found across various parts of Mexico, India, Pakistan, Africa, Australia, and the southwestern United States. Commercial aloe farms often cover hundreds or thousands of acres and are laid out in long, neat rows designed to maximize sunlight exposure, maintain airflow, simplify irrigation management, and create easy access for workers and agricultural machines. Instead of growing aloe vera from seeds, which are unpredictable and slow to mature, producers rely on offsets or pups that grow naturally around the base of established plants. These offsets are genetically identical to the mother plant, ensuring that the entire plantation has consistent growth patterns, leaf size, gel quality, and yield potential. Workers separate the pups and transplant them into prepared fields with wide spacing to encourage strong root expansion, prevent overcrowding, promote healthy air circulation, and allow easy access during harvest. Although aloe vera is a drought-tolerant species, commercial plantations still implement controlled irrigation systems, most commonly drip irrigation, which delivers water directly to the root zone and prevents overwatering while conserving valuable water resources. Throughout the growing period, farmers regularly remove weeds, monitor for insects and plant diseases, and condition the soil with organic matter to encourage vigorous leaf development because the leaves contain the valuable gel used in global industries. Over a period of roughly 18 to 24 months, the plants mature gradually, filling their thick, fleshy leaves with nutrient-rich gel containing vitamins, enzymes, antioxidants, amino acids, and hydrating compounds. Once the aloe plants reach optimal maturity, the harvesting stage begins, and this stage is one of the most delicate, skill-dependent, and time-critical parts of the entire production chain. Even though modern agriculture incorporates machinery in many crop systems, aloe vera leaves are still harvested almost entirely by hand because precise cutting is necessary to avoid damaging the plant or contaminating the gel. Skilled harvesters select only the outermost, fully developed leaves, which contain the highest gel concentration and the lowest levels of aloin, a bitter yellow latex found beneath the rind that must be minimized in high-grade products. Using sharp knives or specially designed cutters, workers slice each leaf off at the base as close as possible to the stem without harming the central growth area, which ensures that the plant continues producing new leaves for future harvests. After removal, the leaves must be handled quickly because aloe vera begins to degrade almost immediately once cut. Exposure to air triggers oxidation, and the gel starts losing its natural potency, clarity, and nutrient value. To prevent deterioration, the freshly cut leaves are transported immediately to collection stations or loaded into crates and temperature-controlled vehicles designed to protect them from heat and contamination. Within a few hours of harvest, the leaves arrive at the processing facility, where they are moved through a series of tightly controlled, hygienic, and efficient steps designed to preserve the gel's natural properties. The first stage inside the facility is cleaning, during which conveyor belts carry the leaves through automated washing tunnels that use rotating brushes, high-pressure water jets, and food-grade sanitizing solutions to remove soil, dust, insects, and any external impurities. After washing, trained inspectors visually examine each leaf, discarding any that show bruising, mold, cracks, or damage that could affect gel quality. The next stage is gel extraction, which combines mechanical precision with manual expertise. Two primary extraction methods exist: the filleting method and the whole leaf extraction method. The filleting method is the most widely preferred for producing top-quality gel for cosmetic, food, beverage, and medicinal applications. In this method, the thick green rind is separated from the clear inner gel. Semi-automatic machines remove the spiky edges, slice the leaf open, and loosen the gel, while skilled workers make fine adjustments and ensure no unwanted latex or rind pieces mix into the gel. The whole leaf extraction method involves grinding the entire leaf and filtering out the rind and latex later. But this method requires more intensive purification and is therefore used more often for lower-grade products. Once extracted, the gel flows into stainless steel collection tanks where gentle mechanical mixers maintain an even texture and prevent separation. Operators continuously check the gel's viscosity, color, and clarity, ensuring that it meets industry standards before stabilization begins. Stabilization is one of the most crucial parts of the entire process because raw aloe gel deteriorates rapidly if left untreated. To preserve its natural compounds, the gel is pumped into pasteurization systems where it is quickly heated to a carefully controlled temperature and then rapidly cooled. This short heating cycle kills microbes and slows enzymatic activity while protecting the gel's beneficial nutrients. After pasteurization, the gel undergoes multiple filtration stages. The initial filtration removes larger particles, such as rind fragments or fibers. Fine filtration eliminates smaller solids. Ultrafiltration removes microscopic impurities and produces a clear gel that meets strict international purity standards. Some processing plants add an activated carbon filtration stage to reduce natural odor and improve clarity, especially for high-end cosmetic or beverage products. At this point, the gel may remain in its pure form if it is intended for pharmaceutical or food applications, or it may be blended with additional ingredients depending on its final use. Cosmetic manufacturers may add preservatives, stabilizers, vitamins, botanical extracts, fragrances, or thickening agents to create desired textures and performance profiles in lotions, creams, hair products, or facial treatments. For beverage or nutritional products, the gel may be mixed with purified water, natural flavors, citric acid, sweeteners, or nutritional additives to improve taste and stability. All blending occurs under strict hygiene procedures to ensure safety and quality. Once the gel is fully prepared, the packaging process begins. Most aloe vera gel intended for industrial use is not bottled into small retail containers at this stage. Instead, it is stored in large bulk containers to be shipped to manufacturers worldwide. Two common packaging systems dominate the industry: intermediate bulk containers, known as IBCs, which typically hold between 275 and 330 gallons of gel, and aseptic bags, which are sterilized multi-layer bags capable of storing hundreds of gallons without refrigeration by preventing oxygen exposure and microbial contamination. Using automated filling machines, the gel is dispensed into these containers through sanitary hoses designed to eliminate contact with outside air. After filling, each container is sealed tightly and labeled with production dates, batch numbers, certification information, and quality control data. The filled containers are then palletized, shrink-wrapped, and loaded into transport vehicles for shipping to cosmetic brands, beverage companies, health supplement manufacturers, pharmaceutical producers, and many other industries worldwide. Aloe vera continues to rise in global importance because consumers increasingly seek clean beauty products, natural health solutions, plant-based beverages, eco-friendly wellness options, and safer alternatives to chemically formulated goods. Aloe vera satisfies all of these preferences due to its long history of therapeutic use, extensive modern scientific support, sustainability, low environmental impact, and ease of cultivation. It grows well in regions where few other commercial crops can thrive, requires relatively little water, and can be harvested repeatedly from the same plant for years, making it an economically efficient and environmentally responsible agricultural product. As global industries expand and consumer preferences continue shifting toward natural ingredients, the demand for aloe vera shows no sign of slowing down.